Hi viewers and listeners of Electronics Class Tanzania. Once again, your coach, Herini Mhina, is about to bring you lesson 5 about transistors. We've been learning transistors for a while now, and we'll continue because we're in elementary stage. Thereafter, we'll be upgrading stage by stages. Today's lesson is about amplifying effect of a transistor. So we'll take a look of common base transistor configuration, and we will have our parameters, and we'll see how it amplify or how it bring the effect of amplification in all the concept of transistors. Amplifying effect, amplifying effect amplifying effect of a transistor. Our lesson will be about amplifying effect of a transistor. Let's have a circuit of a common base transistor configuration. This is a ground. This is a common base configuration. We have our battery source here, and our battery source on the output side. Here we have our load resistor, and we have output voltage VL, load voltage. Here we have load current IL. This is our collector terminal. This is our base terminal. This is our emitter terminal. And here we have our signal VI. So this is a circuit. This is a common base transistor configuration. So the changes in input current with the changes in input voltage, when they change exponential changes, this has an effect of when we have a small change in emitter base. This brings a relatively large emitter current charge. So we can see the relation also of current, of a corrector current. This can be related by, again, this is AC circuit. This is called a large current gain. With the change, this is a change of corrector current and also a change in emitter current. This is it is a relationship between a change in a collector current to relate with input emitter current. So this is a factor. It's a large. It's called a gain. It's a large current gain. Also, we can relate our change in a load voltage is changing. This is just Ohm's law. This is just changing collector current times load resistance. This is just Ohm's law. And also, our input voltage, change in input voltage will be shown as this small r is a dynamic emitter junction resistance. This one r, small r, also can be in times with the input emitter current. This is just Ohm's law. And our voltage amplification is related by shown by A. This is a symbol of voltage amplification. It's big A and a small v. Is equal to output voltage. This is a change in output voltage. This is a small triangle. It shows a small change over a small change in. This is the load VL, and this is the input, output, input. So we can represent also in another way by using our current. So we have seen here that a change in IC can be related in this way, and also the voltage at output is ICRI. So the change of current in, we can collector current can be represented as gamma, which is large current gain, and the emitter current be like this one. This is AC circuit, small AC. It means it is AC circuit, and the small triangle is a small change in the emitter current, which also represents the IC. And because it's just Ohm's law, is current times resistance. So our resistance is RL, our load resistor, over our input. This small triangle means it's a small change in voltage, which also can be represented by this small r, which is a dynamic emitter junction resistance. The small r means small change in emitter or input current or emitter current. This is current. It's a resistance, that's current. So this is our formula here. This is the first formula. This is our second formula. And this is our third formula. Equations. These are just equations. Our third equation. So here is the voltage amplification. So this cancel each other. Just simple algebra. Just cancel each other. So let's assume that this small r is the resistor, but we put a small e also to show that it is dynamic. It is dynamic emitter junction resistance. Let's say it is 25 ohm. So it's 25 ohms, and let's say our load resistance is 5 kilo ohm, and our gain this AC circuit. This is it's called a large current gain alpha. This is alpha, which is a large current gain equal to 0.99. This equation here is minus because the collector current is minus, because this is NPN. It's NPN transistor. the emitter current is positive, so the other collector current and base current are negative. That's why we have negative here. It's because it's an NPN transistor, and in NPN transistor, the arrow goes inside the transistor. Therefore, the emitter current is positive, but the base current is negative and the collector current is negative. That's why we are negative here. So let's put our values here. This is, as I said, is a voltage amplification. So our alpha, which is a large current gain, is 0.99. This is minus from the equation. And also our RL is 5 kilo ohms. That means 5 times 10 power 3 over RE, which is 25 ohms. So here also it will be ohms instead of kilo ohms because we have put 10 over 3. And this is 25. This is also ohm. This is just simple algebra. You use a calculator and you get this figure minus 198 as our voltage amplification gain. This is our 198. This is our voltage amplification gain. So any signal will be amplified 198 times, 198 times. So all the calculations, the parameters, and the configuration shows that how a transistor can be used as an amplifying effect to our circuits. So by using these parameters, we've seen that any signals coming inside will be amplified 198 times. So this is how a transistor is working as an amplifying effect. In lesson 5 today, we've seen how the transistor is an amplifying effect, and we've seen the calculations and how it can be used to amplify signal, any input signal. And according to our parameters today and the configuration of a circuit, we used a common base transistor circuit, NPN, and we've seen according to our data and parameters, any signal can be amplified by 198 times. In coming lesson next week, we'll also be on transistors, so don't miss it. And your coach, Engineer Mhina, will be giving you first elementary about transistors and how it is used in your circuit. So don't forget to subscribe, like, and comment so many can share and learn together in this electronics class Tanzania. Thank you so much.